the way to frame it is like, number one, make sure that you're building a use case where the failure cases are not going to devastate your company. But number two, when you define that use case, you want to have a very robust view about how the agents can perform by creating a curated data set of tests.
Welcome to Partner Path, a podcast that unpacks the venture capital and growth equity ecosystem from a junior perspective. Young entrepreneurs and investors have already had a massive impact on the industry, having started unicorns and launched billion-dollar funds. We discuss these success stories and more by sharing perspectives and advice from some of the industry's most prominent role models. This podcast expresses our views as of the date published and does not represent the views of and is not endorsed by any company for which we work. Before we get to the episode, Laura and I are excited to announce a partnership with Overlap. Fresh out of Y Combinator's summer batch, Overlap is an AI-driven app that uses large language models to curate the best moments from podcast episodes. Imagine having a smart assistant who reads through every podcast transcript, finds the best parts or parts most relevant to your search, and strings them together to form a new, curated stream of content. That is what Overlap does. I personally use Overlap to explore content on future podcast guests and highly recommend it as another diligence tool for investors. Check out Overlap on the App Store today.
Today we are chatting with Alex Reibman, the founder of AgentOps, a monitoring, testing, and replay analytics platform for your agent. Welcome, Alex.
Fantastic to be here. Thanks for having me.
So let's go back in time and maybe share what makes Alex who Alex is today, touch on any pivotal moments earlier in life.
For sure. So I think that my interest in computer science and more broadly machine learning stemmed back from when I was in high school. I was really privileged to have a computer science curriculum when I was growing up, and it was kind of stemming from my interest in video games. I really love this game called RuneScape. And back in the day, this game was extremely grindy, for lack of a better word. So you'd spend hours and hours and hours just trying to doing the same exact thing to level up your character. And so I was really interested in like writing these little scripts or these little bots, or I wouldn't call them agents, but they were bots that could kind of do things automatically for you. And what that led to is I kind of grew interested in programming, learned some Java. And when I was in high school, I had a teacher who offered a game design class. And we basically made some really lousy Xbox games when we were like junior year of high school. So that kind of really got me interested in this stuff. But at the same time, I was really kind of pulled away from computer science because I fell in love with reading philosophy and kind of more of the humanities sides of things. So when I graduated and I went to Emory, I totally abandoned my computer science ambitions and I went all in on philosophy and studying philosophy and economics. So kind of towards the end of my career, this is, I'd maybe been like my junior year, I thought it would be really interesting to take some computer science classes again. I've had kind of a strong passion for that in the past. I was very good at it. And I had this one professor who was just extraordinarily inspirational and a great motivator to me to kind of push myself. He told me that there's no way I could squeeze in a minor, 2 majors, but I could get like an unofficial minor with maybe like an unofficial capstone. And this one class that really stood out to me was on the curriculum was called data mining. Now, I had no idea what that meant, but it was like hands down one of the most interesting looking classes I've ever seen in the entire Emory curriculum. So I decided to force myself to take all like the math and CS prereqs to get into that course. And it was really wonderful for maybe not the reasons I expected, which was it was basically kind of like a subset of machine learning. So we did a lot of machine learning in that class, but also kind of recognizing patterns in large data sets. And what was interesting about that was I was also studying economics at the time, took a lot of stats and econometrics. And what I realized was the models we were using for our data mining course sets were pretty much identical to those of the econometrics. And the economist or econometrician is interested in using things like ordinary least squares or linear regression to find causal effects between variables, right? Like how does education affect income? Whereas the machine learning engineer or the data miner, they're interested in the predictive effect, which is for this subgroup with this income level, how much can we expect them to spend, right? And it was these two different like mindsets and paradigms that people were looking at these fields with that really kind of made me realize, wow, this is extremely interesting. And there's so many applications that I could imagine happening with that. That was kind of like stepped me forward into a career in data science and machine learning after that. In any case, following this, I actually ended up getting a job offer from a company in Tel Aviv, Israel called Checkpoint, which is kind of one of the largest cybersecurity companies out there. It's publicly traded. They're known for like having the first enterprise grade firewall on the market. And I was on their NGAV team, which means next gen antivirus. And we were using basically kind of novel machine learning algorithms to identify malware. So essentially, cybersecurity is pretty archaic in how they do a lot of things. They don't have like a lot of advanced algorithm detection. So anything that's like beyond just checking the hash of a file or checking the fingerprint is considered next gen antivirus. And we were finding a lot of applications for machine learning there. And that really kind of got me interested in saying, how can we take this really profoundly interesting technology and use it to make our lives better? Following that, I did some stints in also cybersecurity, but also consulting for some large tier 1 banks. Worked for one of the largest banks in Australia, JP Morgan, American Express, Goldman Sachs, and built a lot of MLOps tools for that. And that all kind of culminated into a career where I understood the ins and outs of why this stuff is so hard. And a lot of the times, it's not just the stats and the mathematics that makes this stuff hard, which is challenging, but definitely doable. But it's actually kind of like the infrastructure around it. Like, how do you make sure that you have a system that's reliable, a system that's safe, a system that's cost effective? And this all led to me founding AgentOps with my team, which was we realized this new AI tooling from ChatGPT and the large language models. You create these AI agents and they're extremely powerful if you do them right. But the tooling is what makes them actually valuable because you know that they're going to be reliable, you know they're going to be cost effective, and you know they're going to be safe if you have the right tooling in place. So that's a long story short, and I'm happy to dive into any details.
Taking a few steps back, you were deep in corporate, I would say America, but you were working in America. So corporate Israel and working at these large enterprise organizations. How did you make that shift? And then continuing to move around to different enterprise companies that you wanted to go be a founder and work in a startup?
I think I always had something like a bit of a knack for wanting to start a company. So when I was in college, I was probably severely underskilled, and I was severely underskilled. And when I graduated, I actually got into this program that was kind of like a startup incubator or an accelerator. It was like a 10-week accelerator, and I tried building this really sophisticated machine learning algorithm with my team that could basically identify accents, spoken accents. And the way we described it was Duolingo, but for your accent. And what happened was we actually built this really well-accomplished model. It could differentiate accents quite well. And the idea was to help use this model to help teach people how to speak better spoken English. Huge demand for this in the rest of the world where there's call centers. Having an American accent or a British accent has a business premium to it. So we really tried our best to make it work. The challenge was we gave the app to people and they all hated it. And the kind of the key learning there, and it's embarrassing to think about, but it was a really valuable one, was they all told us, I don't need an AI algorithm to tell me I have an accent. I already know that. And it was kind of like a facepalm moment, but that's when I realized like a lot more about just, building extremely impressive technology. A lot of it's about finding technology that solves a real problem. And I learned from that experience alone, just like really speaking with customers and really getting to know their problems extremely well and throwing ideas at them is the best way to understand that you're solving something real. Following that failure, I was totally out of money, but I would love to do kind of like dabble in the entrepreneurship realm. So I do a lot of hackathons. Starting from back then, this was around 2016, I started entering myself into hackathons. And with this core learning, which is just talk with customers, right? Really get a strong sense of what you're building and how it solves a problem. I would go to the hackathons and instead of running right to the code base, I would spend maybe 3 hours just talking with mentors and really try to understand like, what are their pain points? What solutions have they tried? Which ones are working? Which ones are not working? And that way I was able to come up with a differentiated product, a product that solved a real problem, a problem that was like innovative, something that was truly creative. And that was kind of like my success pamphlet for how to win any hackathon, which was like, just talk with people, solve something real, spend less time coding, more time coding something that's valuable. And to this day, my track record is like, I've won something like 17 hackathons. And I've had some really cool opportunities from that. I won a trip to Japan after I won the Mazda hackathon. I won a trip to Germany when I won the Trivago hackathon. I also did a maritime and shipping thing hackathon a number of years ago. And the offering of that was they flew us to Marseille, France to kind of meet with the executives of one of the largest shipping companies on the planet. So it was a really kind of like wonderful, these were kind of like trial entrepreneurship periods, right? Kind of low risk in that I'm not going to do my life to it, but I'm able to build those skills. So there came a point where like, I was thriving and doing exceptionally well at corporate life. I was working as a consultant at a time for one of the big four. And I realized, if not now, when? I have all these skills. I know how to manage a team. I really know the problem space really well. When is the best time to do it, if not now? And so that was kind of like the thing that, made me make the leap and jump into the realm of the arena.
When you were competing at these hackathons, was AgentOps born out of one of your 17 winnings?
It actually was. So I was in San Francisco at the time, and Amplitude, which is kind of like a data analytics company for basically understanding when people churn for web apps and regular mobile apps. I was trying to build an AI agent with my team, and the AI agent purpose of it was to go to every airline. So some context here, I really love to travel. I'm a bit of a travel hacker. I have like 13 credit cards, and all of my vacations are paid for by credit card points because I know the hacks of getting the sign-up bonuses and never spending a single penny on what I don't need to. So I really love to travel, but one big pain point is actually signing up for these frequent flyer programs. A lot of the websites are really, really hard to navigate, and it takes a long amount of time. And my thinking was, what if there was an AI agent that could just go to every airline and sign up and create an account for me? Like, not even book the flights, right? Just create the accounts. So I tried building an agent, and it just failed every single time. It was horrible. So we tried doing that for this hackathon. It was bad. And what we realized was we knew it was bad, but we didn't know why it was bad. It was like sometimes it's going in circles, sometimes it would just crash, sometimes it's context limits. And what we built was for this hackathon was tooling to basically evaluate and observe. Why was it failing? Why was it getting too expensive? Why was it going in circles? And that was the origin of AgentOps, which was the reliability factor wasn't being monitored by anyone. And what we realized was that everybody was having this exact same problem. Anyone building an agent was having the exact same issues. So that basically led us into kind of pivoting the whole idea, which was building verticalized application agents into building the horizontal play, which is building the evaluation and testing tools that make it easier for everyone to get products to market. Because these products are really, really great and conceptually, but we don't have the right infrastructure to make it happen right now.
Before we go too deep into agent ops, can you just define what is an agent and how are companies using agents today?
An AI agent, there's kind of an analogy to think about it. So in the streets of San Francisco, or maybe you've seen them on the internet, we have self-driving cars. So they are driverless cars that just kind of navigate. You give it a destination, and it goes from point A to point B on its own. And it figures out how to solve that path, figures out how to do the mapping. An AI agent is something like a self-driving program in that you give it a destination, you give it an objective, and it figures out all on its own how to arrive at that objective. Kind of more concretely, you can kind of think of this as like ChatGPT. So ChatGPT, you can ask it a question like, what toppings go on a pizza? It'll say pepperoni, lettuce, tomato, onion, whatever. But if you ask it to order a pizza, it will say, I have no idea what to do. I'm just ChatGPT. I don't have tools. I can't talk to the internet. I don't have a credit card. When you outfit a large language model with tools, that's when it becomes agentic. When it has state actuators, when it has a way to actually affect and change the world, that's when it becomes an agentic program. And it's when it's able to reason for itself on how to solve problems. When I just say, here's my credit card, here's my address, order me a pizza, and it's able to solve that on its own, then you have an AI agent. So that's kind of the high level way to think about it. Now, a lot of use cases we're seeing kind of span a lot of different varieties. So the most common we see are text summarization, chat Q&A, and research. So text summarization, pretty fairly obvious, right? You're connecting your data to an agent. It's able to summarize things and create citations, so on and so forth. Chat Q&A, these are use cases where basically you're building customer support bots, you're building agents to answer pull requests, you're building agents to answer all sorts of questions about your documentation, and basically linking that with tools that's able to talk with the internet, pull information from your databases, so on and so forth, and give feedback requests to your human users is super valuable. One amazing use case we've seen is Klarna. Klarna built an agentic support system, and they're saving $40 million a year now. And not only that, the support system has higher customer satisfaction ratings than the humans. So it really does kind of go to show, like, things are very powerful. Lastly is research. So in terms of research, we're seeing a lot of folks who are just connecting all sorts of different data sources. So for example, we have one user, they're basically using it for equities analysis. So they're plugging their agent with Morningstar, with Gartner, G2, and they're using it as basically a methodology of how to analyze different companies and helps their traders make better trading decisions based on information it's able to collect autonomously. So there's usually a human in the loop with these things, but you have oftentimes autonomous programs too. And this is where the frontier research is happening, where you're seeing tools like Cognition Labs Devin, or another one that we've seen recently called SoftGen, which is you give it a prompt and it makes websites all on its own within like less than 5 minutes, 5 to 10 minutes. That's really powerful and really incredible. And I'd say anything that's able to navigate and solve problems for itself would be an AI agent.
Now, a quick word from our sponsor. Laura and I are thrilled to announce a partnership with Grata, an intuitive deal sourcing and diligence platform. Keep missing out on private market deals? Ditch the Rolodex and get Grata. Grata's AI-powered platform provides accurate data, deep insights, and time-saving workflows that help get more deals done. And it's trusted by over 500 firms and 3,000 deal makers, including myself. I've personally used Grata in both my deal sourcing and diligence workflows and would recommend their tool to any investor across private equity, growth equity, corp dev, or investment banking. We've negotiated a special offer for our audience. Mention PartnerPath to the Grata team during signup, and you'll get free executive seats for your partners and MDs included in your subscription. Now, back to the episode. I think it's a fantastic primer on agents, and I think a great transition into maybe trying to understand agent ops. So, Alex, maybe in your own words, can you describe what you're building with agent ops and what is so unique about the business that you're building?
I'm going to show off a little screen. So, listeners at home, I'll try my best to describe. Let me give you a little sneak peek about what we consider to be agentic and agent ops. So underlying everything in an AI agent, you have large language models. So large language models are basically the decisioning engines that make agents work, how they're able to solve and navigate the tasks. But when you connect it with tools and function calls, that's when it truly becomes agentic, when it has the state actuators. Now, there's a lot of other metadata that comes into play when you're building out an agent. So for example, your agent ID, the state, the metadata attached to it. But also you have the context history, right? What other interactions has it had with other agents or other humans? What's the name of the model that you're using? What's the context limit of the model? How much of your context have you used so far? So on and so forth. We're also seeing a lot of folks who are implementing memory into their agents. So you can plug in vector databases. You can have time-aware vector databases, right? So instead of just doing RAG queries and asking questions about, suppose, the news, you can ask news that's time variant, right? Time aware. And that's extremely powerful too. Things like planning managers, understanding how your agent thinks and reasons through problems. Those are things that we try to observe and track. Action histories. And then lately we've seen this as a very massive trend, and this is where we tie in very, very well with the ecosystem, is multi-agent tenancy. That is, when you're developing a program, you're not just having one agent, you actually have multiple agents that work together to solve problems. So for example, if I'm writing an agent that writes a job post for me, I might be interested in having an agent that searches the web, but also an agent that writes the job post. And then also an agent that summarizes and edits the job post for me. And they all work together in these collaborative fashions to solve problems. So with agent ops, what we've been really focusing on is gathering all the aspects of the stack I just described. But on top of that, one really key learning we're trying to do is integrate with the most popular frameworks out there. So for example, Microsoft has a popular multi-agent framework called AutoGen. And AutoGen is, for those unfamiliar, it has this conversational workflow pattern where you can develop orchestrators, you can have team managers, you can have chat rooms, or you can have one-on-one conversations between agents. And we have first class and first full service integration with Microsoft's AutoGen so that you can observe and track and monitor and really understand the agents. Same thing with another agent framework called Crew AI. So Crew AI is another similar thing where you give agents a goal, a backstory, and a task list, as well as a set of tools. And they all, you can spin up as many as you want, and they work together to autonomously solve these problems. And again, we're a full service integration partner with Crew AI, and we make it really, really easy for folks who are using that open source framework to get observability and basically be able to see everything your agent does. So what that generally looks like is, I can share a screenshot of this. You basically get dashboards, right? So at the end of the day, I'm going to share my screen again. As for folks at home, I'll try my best to describe. So essentially, you can organize your agent workflows into projects. And when you do so, you can basically get these dashboards that show things like how much you're spending on large language model costs, how many tokens you're spending per session. You get detailed analytics charts, pie charts, show that things that show indeterminate states, failed sessions. But most importantly, you can actually drill down into individual chat logs and see exactly what your agents are doing at any given point in time. So those are things like the environment you're running on, right? Are you running on a Docker container? Are you running it on your local laptop? How much money did you spend, right? GPT-4 is expensive. We all know this, but how much is expensive per run? How long did it take? Some agents take a very long time. I've had agents take 30 minutes sometimes and cost me tens of dollars. But kind of most importantly, it's really hard to build agents for one reason as a developer, which is they're very yappy. And that's a technical term, by the way, yappy, which is they just spew out a lot of text and a lot of tokens. So one thing that we built out into the platform is the ability to really see all the chat logs and everything that your agent does to chat or to reason or to solve problems. It's this like nice chat viewer. And we also have these waterfall diagrams that show you step-by-step how agents are talking with each other, especially when they're multi-agent, whether they're using tools, whether they're having errors, and what kinds of actions they make that actually make them agentic at the end of the day.
As investors, Laura and I love seeing waterfall diagrams. So that last point really stuck out to us. You mentioned GPT-4. I guess I'm curious to hear how the continued improvement of foundation models and various improvements in performance there have impacted your product that you're creating?
So we've been seeing enormous amounts of growth, and not just in the GPT ecosystem, but a lot of folks who are running open source models. So the two biggest providers we actually see with our platform are Llama and Grok. So basically they're using kind of the Llama class of models or the Mistral class of models. These are the two most popular outside of OpenAI. So to consider this, like we're seeing a lot of folks who are kind of shifting away as the token is becoming somewhat commodified. But in addition to that, one big challenge with large language models is they aren't exactly the best reasoners when it comes to tool calling. So we're also seeing a lot of folks who are adopting models that are specifically devised for just determining whether or not to use a tool. So if an agent is clueless about whether to search the internet, you might have a different LLM as a sidecar that says, hey, I think you should search the internet because you're having troubles with this. And so we're having a lot of agents that use these kinds of third-party models, like from the Gorilla Lab at UC Berkeley, as well as things like Nexus Raven. So it's still very early, right? One big challenge with these agents is we don't really know what the best algorithms are right now. It's a lot of experimentation. And building a really tight experimentation pipeline is actually what we need to arrive at a better conclusion. One big challenge right now is people don't have pipelines. They don't know how to have rigorous tests. They don't know how to set up evaluation chambers. And that's basically what we're trying to do with AgentOps, which is A, offer the observability front, but B, offer the ability to test and understand your tests so that you're able to build more powerful agents.
We wouldn't be investors if we weren't highlighting the business model. I think it'd be really helpful to maybe walk people through how AgentOps is actually generating profit and charging their customers. Obviously, you have the cost of the large language model and the compute there, but how are you typically charging customers?
So you can kind of think of us like a classic analytics play. So we don't actually charge for large language model inference, and we don't actually charge for any of the tools. What we charge is for throughput. So the more that you're using our product, the more that you're actually spending with us. So you think about it like this. We attach a certain dollar price tag with every event that you send to the platform. And then with that, you're only spending as much as you're using. So if you're really playing around with agents, it's practically free. In fact, it is free for most of our users who are signing up for the first couple of days. They're not spending anything because they're just, they're playing around. They want to get better observability. But as you get closer to production and you're going from running maybe 5 or 10 agent runs per day to thousands, that's essentially when we start metering the service. So if you want to get full observability and basically save your logs, save your replays, and be able to understand the statistics about how your agents are working in production, that's where we come to help. Secondarily, and that's how we take from the product-led growth perspective, which is we really try to build the best possible tools for the ecosystem and really just hone in on like what makes the developer experience as delightful as possible. Because right now it's really like you're going through yappy logs. It's really miserable. And just trying to focus on that helps us a lot. Second to that, we actually work with a lot of enterprises to help get their agents to production. We do offer things kind of along the lines of architectural consulting, but in addition to that, a lot of folks who are in the enterprise stage of things and they want to deploy their agents to production, but they don't have a good observability solution. We do things like self-hosting and support, and we also build out custom modules and dashboards that make it easier for their bespoke use cases.
And you mentioned Devin Cognition earlier. Laura and I have spoken with Div at Multion. I guess there are other agent developers out there and creators of these types of platforms. I'm curious to hear your thoughts on maybe some of the other producers of agent platforms and maybe any lessons learned from other products out there.
Absolutely. So I think I'm a huge fan of Cognition because for one reason alone, which I think they have a masterful user design. So it really, to the layperson who knows nothing about agents, it's extremely clear what the agent is doing. And I think to the developer, it's really a power tool. I think they've done a wonderful job there. And then tools like Multion, they're actually one of our design and integration partners. So if you actually use the Multion SDK right now, it's automatically plugged in with AgentOps. And it's set up in such a way that if you run an agent with Multion, you essentially get screenshots and videos that show tracking what your agent was doing at every step in the process. We're kind of big and leaning in on that also. In terms of cool agents that we're seeing out there, I have a really cool link you can check out that we manage personally. It's called staff.ai, STAF.ai, where we actually personally curated over 300 different agents, open source, closed source, and for a variety of different use cases. We're seeing executive assistants, code gen agents, we're seeing research agents, everything, across the spectrum agents that we've been tracking and monitoring to make sure that people who are really curious about these tools can get access to them.
I think an agent is only as good as the data that it's trained on. So I'm curious, how are you prompting it to solve problems better? Are you implementing different RAG-based solutions or just calling an LLM enough for the use cases that enterprises are using agents for today?
So what we've seen that have the most success is kind of a technique called in-context learning. So basically providing examples in the prompt and in the system prompt of of your agent helps a lot in terms of how to give it offer direction and guidance. That said, I don't want to make any strong claims about really what the right techniques are for guiding these agents. On one end, we're actually kind of disconnected as developers and people who are close to the application layer. We're very disconnected from what the large language model providers are making because, they have infinite compute essentially, and they have millions, if not billions of dollars to do so. What we have been seeing is a lot of folks who are fine-tuning cheaper and more effective models than what's off the shelf. So, for example, one of our partnerships is with a company called OpenPipe. And OpenPipe, they basically can train a fine-tuned version of an open source model that is 25 times cheaper and equally, if not more effective than GPT-4. So essentially what we do with them is when you log your agent runs with Agent Ops, you actually have a curated data set already because you know what your agents are doing. And with that curated data set, you can fine tune that cheaper large language model and then plug that into your version 2 of the agent and see how it performs. It's going to be faster and cheaper. That said, in terms of just prompt engineering in general, there's a lot of debate academically speaking, but I think right now, what's really wonderful about agents is that you get really far with just kind of like minimal experimentation. Prompt engineering is not that hard at the end of the day. It's just really how much time and effort you're willing to put into it.
Agreed with all of that. And with the time and energy and what you're putting into it kind of leads to this world, an agentic world, we'll call it. And I'm curious, how do you view the future as everyone is using an autonomous agent with the least amount of hallucinations? So almost having an agent, what % can we get to of us being able to rely and trust an agent to do tasks for us?
So leading back into, I guess, my experience in the world of machine learning, you have the exact same issue, which is how do you want to trust a system that cannot deterministically produce the correct results 100% of the time? And this is going to be the case across the board. And sometimes you have higher risk than others, right? So in the world of malware, if you have a false positive, there's really no consequence, right? You flag a benign file, say, document.txt is malicious and you can't open it. Big deal, right? But if there's a false negative, if you let one piece of malware get through, your company is sunk, right? You're not going to be a good vendor. So it's really thinking about the trade-offs here between the type 1 and type 2 errors. Which ones are you willing to accept? Are the failure cases going to be dangerous to the point that it endangers your business or potentially endangers other people? So these are the business and oftentimes philosophical questions you need to adopt when you're thinking about agentic systems. Now, with that said, I can give you more concrete answers, which is having a very robust evaluations pipeline is the number one way to make sure you're building systems that work at scale and are not going to let users down. This is actually a product that we've built into the Agent Ops platform. I'll share my window again. Again, I'm not entirely sure everyone from homes can understand what's going on, but happy to kind of give visibility into what we have. So essentially what you can kind of do is you can define configuration files. So a configuration file you can think as a set of system specs that basically say, hey, here's test number 1, here's test number 2, here's test number 3. And so what we're looking at right now is a test on an evaluation set called WebArena. WebArena is a open source evaluation kit developed by a team at Carnegie Mellon. They created a bunch of fake websites that you're basically, webarena.dev is the domain. You can basically test your agent against a variety of different fake websites, like a fake version of Reddit, a fake e-commerce store, a fake version of Wikipedia, so on and so forth, and ask them to try to resolve questions based on just this alone, see how well they navigate. What we can do here is WebArena is actually a set of over 800 different JSON configuration files that state things like, what is the URL you are checking? And also, what is the question? So for example, I'm looking at one right now. It says, what is the top selling brand of Q1 2022? And the answer should be Sprite. What we can do is actually go to this website here that they provided. It's a fake version of like this e-commerce store dashboard. And the goal is to task the agent to try to log in, navigate the dashboard, and answer the question. And if the answer is anything from Sprite, that means it's failed the evaluation. And that means it's unreliable, right? But if it's able to do it well on 98% of the tests, then you might have a reliable enough agent. So I think, the way to frame it is like, number one, make sure that you're building a use case where the failure cases are not going to devastate your company. But number two, when you define that use case, you want to have a very robust view about how the agents can perform by creating a curated data set of tests.
That was helpful. Also kind of brings up the point of this issue of like access-based control with agents, because I'm sure a lot of these companies are building, and this is an assumption here, internal use cases instead of external use cases. So let's say I have an internal chatbot for my employees to ask information about my company. However, depending on the role and the level in the company, the information granted to you will vary. So Is this being solved today by role-based access, or can we implement an agent or an LLM to kind of dynamically help provision these controls?
So I think at the most brutalist level, what we're actually seeing is code sandboxes. So there's kind of a famous scenario where there's an AI agent called Open Interpreter. And what Open Interpreter is it's basically an AI agent that takes control of your terminal. And you can just tell it like, hey, I want you to organize my downloads folder for me, and it'll do the job. However, without correct, access permissioning, it can actually go awry. So there's a famous use case where one guy basically posted on Twitter that they asked their Open Interpreter agent to delete every JSON in a directory on their computer. What the agent then proceeded to do was delete every JSON on that computer. So that's when one of these use cases really went wrong. Now, one way to solve this is basically sandboxing your agent in virtual machines or sandboxing them in containers where they can't go to the outside world or can't go outside of the user space provided to it and do malicious or potentially wrong things. So I think from that perspective, adding permission there is super valuable. We're also seeing folks who are offering basically payment wallets or things like this. It's an interesting company called Payman where they're essentially giving agents the ability to make transactions with each other, to buy APIs, make purchases on the web, so on and so forth, with expiring credit cards. So I think it does end up boiling down to, how much you trust them. I personally would not trust an agent with my credit card if I can't even trust it with my JSON files. But at some point in the one way or another, you're going to be creating these scenarios where they do need permissioning. Although right now, I think just getting them to work is probably the biggest scenario. And the best Band-Aid patch approach right now is just sandboxing them.
Very interesting. I think that concept of sandboxing is obviously very important. Maybe kind of circling back to the question around large language models, and it sounds like you guys are able to work with multiple different providers. I'm curious how the continuous kind of stream of research and product development that's going on, seems like weekly at this point, has influenced your approach to building. What new tools have come out that have helped change or reorient the way that you're looking to build agent ops today?
One of the biggest things that we've been focusing on is basically keeping up to date on all the large language model providers. So right now we support over 400 different models. Our team moves extremely quickly on making sure that everything is up to date as soon as it happens. And in fact, as we're speaking today, Llama 405B, which is a frontier model that surpasses GPT-4 and is entirely open source, just came out. And we also have updated for that right before this podcast. So to think about it like this, it's basically keeping a pulse on what's going on here. And automated hooks are automated hooks to understand what things are going to affect your agent. So the reason why we're able to update so fast is we created these hooks that essentially, as soon as the price registry is set up, we can, basically add support for it. So basically future-proofing the company in such a way that we know exactly how agents are chatting with each other has been kind of our main prerogative. A lot of it is in the research realm. And the real way that we're able to check and keep our product up to date is by speaking with real developers. We at Agent Ops actually manage one of the largest AI agent developer communities on the web. So we have an extremely popular Discord channel called Agent Group. We also have a Twitter group called Agent Group. And we have 200 plus of the top agent developers, including the folks from LangChain, from GSPy, from Instructor, more than you can name. Also, Crew AI and AutoGen are very popular in there. And just by keeping up to date with the folks who are actually developing the agents, we're able to essentially really understand where the needle is moving towards.
And something you mentioned earlier that I think is really powerful and I want to double click on is the idea of agents working together. And then if you kind of parlay that with the example mentioned earlier on cognition, I know that they have been able to scale to, I think, thousands of enterprise customers at this point with 15, 20, 25, whatever it is, full-time employees, because they're actually able to leverage 100 plus devins, right? And so I'd love to get your thoughts on where the future of company building is impacted by these agents. How are people going to be more efficient? How are companies going to be more efficient in the future as leveraging these agentic type software and platforms is able to penetrate into business building?
So I think the closest analogy is to thinking about agents or even just large language models as a Gutenberg moment. So the invention of the printing press. And who invented the very most from the invention of the printing press at first? It was actually the people who were literate, the literate class, who they knew how to read and write books. Now they could produce them at scale. But ultimately, what ends up happening is it ends up propagating as people learn how to read and become literate. I think this is basically what's going to happen with the agentic systems, which is people who really understand this stuff are going to benefit the most at first until it propagates across the world. I'm not saying there's going to be a Christian-style evangelism of agents, but I do think that folks are going to actually interact and interface with these things as never before. We're already seeing this a lot with ChatGPT and even tools like Midjourney. People are learning how to prompt. They're still very new to it, but they're still learning how to prompt. Once larger enterprises really realize this, once they become literate in these tools, there's going to be a much wider adoption scheme where they say, oh, instead of hiring software developers to build an application for me, I could get 80% of the way there with Devin. Or instead of hiring an executive assistant to answer my emails and organize things, I can hire an AI agent that sits in my inbox and does this for me. Or sales outbound agents that send emails and answer phone calls and all these kinds of things. So once people become aware of the tooling and all the really cool use cases out there, then I think it's actually going to have massive scale. We're still super early. We're at the bottom of the S-curve, as they like to say. And it's only going to get bigger.
Yeah, and you've mentioned coding and you've mentioned some email work as well. What's one role that you think people should keep an eye out for? If someone listening is in that role, they should go and check out agents today.
So I think that coding and executive assistants are some of the most obvious use cases. But one of the biggest challenges that I've had personally is just doing very good research. And I think that there's so much wonderful information on the web, and Google does not do a fantastic job of answering. We're seeing really cool tools like Perplexity that make it easier to index this kind of stuff. And I think that there are some agentic workflows that they're figuring out how to work on. But more to me, I think that the biggest use case that we're going to see is with all of our devices. I think that in general, devices are getting smaller, they're getting faster, and they will become more energy efficient to the point where we're probably going to see large language models in every piece of hardware that ever comes out. So thinking about it like this, which is we're seeing this with Copilot on Windows. We're probably going to see Copilots on Mac OS. We're going to see agents with Google Dot. We're going to see it with Amazon Alexa. Thinking about how we have all these disparate APIs and services, we're just going to see like a larger paradigm shift where previously you had developers talking to APIs. Now you have developers that can talk to agents, and then agents can talk to APIs, and agents can talk to agents. They can all solve their own problems. So our forecast is over the next 2 decades, 80% of the programs that are going to be written are going to be agents. And that's no exaggeration because the agents are going to be able to write programs for themselves. And that's why they become super powerful. We're building the machine that builds the machine. And that is why essentially the adoption scheme is going to go so crazy.
And I think another name that we have to bring up before the episode ends is OpenAI. And the OpenAI APIs and their kind of impact in the general agentic space. Where does this fall in their feature pipeline? And what does the risk of OpenAI pose to startups innovating here?
I think the biggest piece of feedback that I've heard from folks who work at OpenAI is you shouldn't bet against the models getting not better. The models will get necessarily better. And if you're building a business that is essentially betting on the fact that the models will only become tokens for text, you're probably going to be wrong because now they do voice and images. If you're betting on the models only understanding a certain amount of how to read context rather than retrieval, you're probably betting wrong. So if you're building tools that just rely on the model staying stagnant, you're probably going to lose. But if you're betting on the models getting progressively better, then you're probably in a good marketplace. We've kind of done something similar to this where we built a business that was killed by OpenAI. It was a small side project called Chat OCR. We basically learned that ChatGPT had a lot of issues reading PDFs, specifically PDFs that were photos and images or scans or faxes. And we built a very simple OCR tool that ChatGPT could just basically take the text from that and then help out users by reading the PDF documents. And we made a lot of money on this plugin. We made over $25,000 at over 40,000 users, and it took us maybe like 2 weeks of work, and it was totally autopilot money. But then GPT-4 Vision came out. What GPT-4 Vision was able to do was actually read pages, and not just pages of text, but actually images. And so basically the model became better and essentially killed our business, right? It wasn't a business we cared about too much, but placing bets that the models won't be able to read different kinds of data, won't be able to read it faster or have longer context windows, you're betting in the wrong direction. Always bet on the models getting better.
And work with the models.
Exactly.
How about we end with a quick fire round?
All right, set it off.
Probably won't be that quick, but what is your favorite type of agent on the market today?
Very big fan of code gen agents. One that just came out that I'm a huge fan of is called SoftGen. It makes websites using Sonnet 3.5. It makes really cool landing pages super fast. I also use Cursor very, very aggressively. It's probably my favorite AI tool. It writes code for me, makes me a much more efficient programmer.
What % of work can agents realistically automate moving forward?
It's a hard question to answer because it's a hard way to define work. I think that most processes that a human could, things like note-taking, transcriptions, video editing, I think a lot of the things that are very monotonous, that you know are monotonous, can be automated. But that said, a lot of things do need human insights. The one thing that will never get automated, and the one reason I don't think that AI apocalypse is ever going to happen, is humans just provide way too much context in what the agents need to actually get their jobs done. I'd say 99% of what makes a good agent is good human context. So pessimistic that they're going to take all of our jobs. They're definitely going to make us way faster, though.
And are enterprise companies ready to deploy agents in production?
A handful of them are, actually, especially on the three I listed earlier: text summarization, chat Q&A, and research. We're seeing a lot of enterprises actually adopt these right now, and they're extraordinarily helpful. That said, I think that one big challenge is data privacy and inertia around adopting new technology. And the best way, if you're an enterprise trying to adopt new technology, is really just try it for yourself and really understand and be creative about what are the possible applications here. We spoke with a lot of large banks that have somewhere between 100 and 200 different use cases for their agents. And that makes it very, there's a blue ocean to be had there, but there's a lot of institutional inertia that makes it a lot slower than it needs to be. So identifying the use cases is probably the number one bet, but a lot of people are adopting them right now.
And what's the top risk of deploying an agent? And you can't say not using agent ops.
Well, that is the top risk. But more broadly speaking, it actually is not using agent ops, because every time your agent makes a step or makes an action, you should know what's going on. If you ask your agent to buy a pizza and it buys 500 pizzas and you have no data trail, you have no way to audit that, then your agents are never going to work in production. So building a really strong evaluation and an audit pipeline for your agent is essentially what bridges the gap from prototype to production. It is what agent ops does. But regardless, you do want to have some sort of safety protocols in place to make sure that your agent behaves as expected.
Alex, what a fun episode. This has been great covering all things agents. I've learned so much personally, and I hope everyone listening does as well. Thanks so much for coming on.
Yeah, wonderful to be here. If you're interested in learning more, check out agentops.ai. We have links to our Discord community as well as Twitter. We're super active on both platforms, and we're happy to either brainstorm ideas with you, help you if you're building agents for enterprise, happy to help with that. If you're just experimenting, happy to help with that. And looking forward to getting in touch.